So how this relates to confidence intervals is that we now have an estimate of the standard error and an idea of the shape of the sampling distribution. Everything at the top of this, everything up to about here, is really stuff that we established in the previous section, right? That introduction to confidence intervals. But in that section, we really had to be given the standard error, and we had to be told that it's reasonable to assume the sampling distribution follows a roughly bell-shaped distribution. So here what we can do is look at our Bootstrap distribution and be able to tell both of those things. Does it look approximately bell-shaped, and what is an estimate of the standard error? But just as a reminder of what we saw in this refresher stuff, our confidence intervals are always of the form sample statistic, which is our estimator, plus or minus margin of error. So we add and subtract the margin of error to the sample statistic to get a lower bound and an upper bound. And we always write them with the lower first and the upper second. Even though when we talk about it, we say plus or minus, which suggests that we would calculate the upper bound first. So that's something to be a little bit cautious about. Also, we saw that the margin of error can be estimated as 2 times the standard error if we have a 95% confidence interval and an approximately bell-shaped distribution. So let's look at the distribution that we created for the correlation. Whoops, wrong one here. Does this look approximately bell-shaped? I would say it's not perfect. It definitely shows a little bit of left skew, but it looks fairly good. It's not way off. So we'll say yes, fairly, but it's noting at least to ourselves that it's not perfect, and so it may introduce a little bit of error using the 95% rule. Yes, with some error. And what parameter can we estimate from a sample correlation R? Well, for this we need to think back to the list of sample statistics and parameters that they estimate, which is in section 3.1. So just briefly, this table here is what we're talking about. So we have correlation, sample statistic R, population parameter, the Greek letter rho. So we're going to put that as a rho. Make sure we know that that is not a P, that's a Greek letter. So we draw it distinctly differently from our P's. We don't put the little serif that the P has. Otherwise I can't really tell whether you meant P or rho. Okay, so all this is good. We're going to use the correlation as our sample statistic from the original sample. So correlation from the original sample, that is my sample statistic, which in this case is R. And the standard error from our Bootstrap distribution to find a 95% confidence interval for this parameter. We said that that standard error, that estimate at the time was 0.018. We could look back in our notes, or we can look back at the Bootstrap distribution right now. That was standard error here, 0.018. So based on just these things, we can find a 95% confidence interval. What we do is we first calculate the margin of error as 2 times the standard error. So that margin of error is 2 times 0.018, which is 0.036. Then we take our sample statistic plus or minus our margin of error to get my sample statistic, if you recall, was 0.914, but let's just look at that again real quick and see where we find that. I'm taking this from the original sample. I am not taking it as the mean of the Bootstrap distribution. Even though in this case they are exactly the same, sometimes they're not exactly the same. It depends on how many samples you generated and how lucky you got with your random generation. But technically we should be centering our confidence interval on our sample statistic always. So I'm going to take that 0.914 and I'm going to add and subtract this 0.036 to get, I'll first calculate my lower bound. So I'll subtract first 0.914 minus 0.036 gets me a lower bound of 0.878. And then I'll add to get my upper bound 0.914 plus 0.036 gets me 0.95. So that's my confidence interval. And now I want to interpret it. Before I start my interpretation, I really want to think about what parameter this estimates and write out the crude version of the interpretation first. So I'll write that above. My crude version is that the parameter rho is in the interval from 0.878 to 0.95. Or actually, better yet, let me back that up and say the crude version, a slightly better crude version, is to say that rho is between these two numbers. Then, to interpret the confidence interval, all I really need to do is fill in what rho actually is. So I have to think back to what's my population and what's my population parameter. Recall that this is marriage licenses, and that in the original framing of this problem we said that we would go ahead and assume that this sample is representative of all marriages, all heterosexual marriages in the US. So we're talking about the correlation between the ages of husbands and wives for all marriages in the US. All of this has to come into my interpretation. So we know that that correlation is between these two values. Correlation is a unitless measure. It's not measured in inches or pounds or anything like that. So there are no units to actually put into this interpretation. But if units apply, we want to include them. So I'll go ahead and fill in an interpretation now. I wrote this as with 95% confidence, the correlation, we have to say what parameter it is that this represents, between ages of husbands and wives for all heterosexual marriages. We need to make it clear that we're talking about the whole population. This is not just a statement about our sample, is between these two values. And no units in this case because correlation is unitless. Generally, we would include units if these were means, right? If we were talking about bounds on a mean, an average of something almost always has units that we could express.